Hello, welcome to another episode of our Year 10 Physics Revision, and this time around we're focusing on Section 1. And the first question we're going to look at is this. Section 1 question on distance or displacement time graph for a person taking a walk. So, the first thing you need to remember about a displacement time graph is that when you see an upward slope like this, what does it represent? It represents a constant speed or a steady speed. And here, so this is a steady speed. And what does this other one represent? The flat line here represents stationary. The downward slope represents steady speed, but going back, reversing at steady speed. So what a good student would do is to quickly label that kind of graph when you see them in the exam. And so whatever question will be asked you later will just fall into one of those stuff. So the gradient of a slope and of a distance time on a distance time graph, so will be distance over time, which is the same as velocity or displacement over time. And for this particular graph, if you look at that is 60 meters, that's 30 seconds. So now let's look at the question. How fast is the person walking during the first 30 seconds of the walk? Show how you obtained your answer. So how do I obtain my answer? 30 seconds here. I trace it up. 60 seconds there. So I know the speed will be given by distance over time, which is 60 meters over 30 seconds. And that will be exactly 2 meters per second. Describe what the person is doing during the next 15 seconds. The next 15 seconds is from here to here. If we trace that up, that represents exactly the flat line on the distance time graph, which means the guy is stationary. So we can say he's resting, okay, or stationary, or not moving. What is the person doing during the last 15 seconds of the walk? The last 15 seconds is from here to here, and as you can see, that is a downward slope. That means the guy is going back, reversing at steady speed. So you can either say he's going back, but you must never forget at steady speed. Steady or constant speed. Okay, or velocity. At this stage, you can use either speed or velocity, and you will never be penalized for that. What is the average velocity of the person during the first 45 seconds of the walk? Now, the first 45 seconds is from here to here. If we trace it up, the total distance covered in that time is 60 meters. So you say the average velocity should be equal to total displacement over total time. Total time. Now, total displacement here will be 60 meters. Our total time will be 45 seconds. And if you work that out, it will be approximately 1.33 meters per second. And that will be your answer here. You can leave it to one decimal place, or you can leave it to 3 significant figures. And that is how you do a question like this.